Welcome to the Oklahoma State Environmental Health and Safety Department machine guarding training. My name is Greg Hogan. I'm a safety training officer here at Oklahoma State University. Today we're going to talk about OSHA regulations, where dangerous mechanical hazards can occur. We'll also cover mechanical motions, different types of machine guarding, safety devices, and of course employee training. OSHA regulations specifically state in different parts, as you can see there on the screen there, not only does it cover machine guarding, but also covers power tools. It also covers the lockout-tagout process, woodworking materials, machinery, mechanical power presses, mechanical transmission apparatuses, all the things that we've just covered within the OSHA regulations. It does require machine guarding. Topics covered. Once again, identify dangerous parts of machinery. We'll talk about that. Identify hazards and actions and motions of machinery. Identify methods of basically safeguarding. A good rule of thumb is any machine part, function, or process that may cause injury must be safeguarded. Where the operation of a machine or accidental contact with it can injure the operator or others in the vicinity, the hazard must be either eliminated or it must be controlled. Where dangerous mechanical hazards occur, dangerous moving parts is in these basic areas require safeguarding. Point of operation. We'll talk about nip points. We'll talk about pinch points. We'll talk about power transmissions and other moving parts. Steps of machine guarding. Machine guarding safeguard basically is the application of a safety, engineering, work practice, administrative controls to prevent the injury of employees who operate machines or who are in the vicinity of a machine's operation. There's a few primary steps of machine guarding, which include you need to recognize a hazard for identifying hazard actions and motions. Also need to analyze the workplace, prioritize safeguarding efforts based on the most predictable injury, the probability of occurrence, and availability of resources. Next one, develop and implement a systematic safeguarding program, which includes identifying safeguarding methods, selection and installation, and also ensure use of safeguards and reinforcement programs by training, education, and also through enforcement. Talk about hazardous mechanical motions. It's a wide variety of motions and actions may present hazards to the workers. It may also include movement of rotating members, reciprocating arms, moving belts, meshing of the gears, the cutting of the teeth, or any part that impact or shears. Different types of hazards, mechanical motions, and actions are basic, and verifying combinations in nearly all machines and recognizing them is the first step towards protecting your workers from danger that are present. There's several different types of what they call mechanical motions. The first one at the very top of the screen, this one right here that we're moving the little mouse around on right now, talks about rotating motion, or things that are going to be spinning. If it spins in a circle is what we're looking for there. Anything that's going to be in a rotation type of a motion. Then, of course, you get the reciprocating motion. Once again, that's going to be back and forth type of a motion. And then, of course, you get the transverse motion. In other words, it only goes one way. Those are the three types of mechanical motions that a person may experience in the workplace. Let's talk about rotating mechanical motions. Rotating motions can be dangerous, even smooth. Slow rotating shafts can grip hair and clothing through minor contact force with the hand, arm, in a dangerous position. Injuries are due to contact with rotating parts, and once again, they can become very severe. Rotating coupling, once again, with projecting bolts. If you look real carefully right here, you can actually see the bolts that are projecting. Would this be a machine guard hazard you need to look for? Most definitely it would, because once again, the nuts and the bolts are what? They're basically penetrating directly through the coupler itself, and very easy to get something in contact or come in contact with that particular spinning or that particular rotating device. The other picture to see over talks about rotating shafts and pulleys with projecting keys and set screws. Here's what we're talking about here. If you look right here, there's a set screw right there. And over on this side right here, the bright yellow bar, that's actually what they call a keyway or a key, projecting key, as far as what holds that particular item together with the shaft itself. And then, of course, you get reciprocating motion. Reciprocating motion may be hazardous because during the back and forth or even the up and down motion, a worker may be struck or caught between a moving and a stationary part. Good example of that, they do give you there is the gentleman that's up against a solid brick wall. The particular machinery he's working around or in that particular location has one specific type motion and basically it goes directly back. It's what they call a reciprocating mechanical motion. A transverse mechanical motion. Once again, it's usually going to be a movement in a straight continuous line, creates a hazard because workers may be stuck or caught in a pinch or even shear point by the moving part. A good example of this would be something that's belt driven. As you can see right here, the belt runs directly over the top of the pulley, but the thing about it is it's a continuous transverse motion. It goes in the same spinning, the same rotating motion throughout the whole process. Cutting mechanical motions. Cutting actions may involve rotating, reciprocating, transverse motions. The danger of cutting action exists at the point of operation, and this is important, where the finger, arm, or body parts can occur and where flying chips or scrap materials can strike the head, particularly in the eyes and the face area. This right here is what they consider as the point of operation, this area right here. In other words, where you have the surface and you have the cutting mechanism where the two come together. And that's what they call a cutting mechanical motion. Here's an example of a punching mechanical motion. Once again, punching action results when power is applied to a slide ram, for the purpose of blanking, drawing, or even stamping material or other type of materials that you may find. Normally what's going to be is going to be one specific type of a die setting, and it just continuously cuts out or punches out that particular product, and that's what they call a punching mechanical motion. You also got another type of motion that involves bending mechanical motions. Bending action basically results when power is applied to a slide in order to draw or stamp metal or other type of materials. In other words, this fixed die right here that you see is pushing down, it's a specific shape. And once again, they put a piece of sheet metal in here in between this location. And as this particular metal stamp comes down, that sheet metal is going to form in whatever shape that particular stamp metal's going to be shaped in at that given time. And of course, you got shearing mechanical motions. Remember, shearing involves applying power to a slide or knife in order to trim or even shear metal or other type of materials. In other words, it's going to come down, it's going to have a shearing off effect, or it's going to have a cutting motion with that particular mechanical motion that you may see there on the screen. This kind of breaks down some of the different types of motions that we've talked just a little bit about and give you some illustrations. The first one's what they call nipping or nip points. As you can see, virtually a nip point basically is where you have a pulley. This particular picture that I'm hovering over right now with the mouse actually involves a belt type system. This one down here actually involves a gear and a chain. But once again, these are the nip points where the gear and the chain come together. Here's another example of a nip point right here. If you look directly on what they call the tool rest on a grinder, this particular tool rest right here, that's going to be a nip point, basically where the tool rest is and where the grinding wheel come in contact. That distance in between is where you're going to find that location at. And then, of course, you got cutting hazards. There's all different types of cutting hazards that we talked about just a little bit earlier. But normally the cutting hazards is going to be at a fixed location. as far as wherever it's going to cut. And then, of course, you got what they call crushing hazards. Remember, crushing hazards is going to be something that's going to be pushing against the body, and usually it's going to be a solid surface directly behind that person's body as well. And basically, is the individuals become sandwiched between the crushing hazard, but also with the wall itself or the machinery, is where a person will actually have some issues there. Machine guarding methods. There's several different methods you can actually apply. First one, of course, involves a guard. It is a physical barrier to prevent access to danger zone or even the area itself. That's considered as a guard. You got safety devices, maybe such as a stop, a restrain, a physical barrier. Operator must use both hands. Be some type of a safety device that person's going to have to physically, once again, keep them away from that particular location. Guarding by location. Hazardous areas basically are not accessible due to physical distance from the operator, and the hazardous area basically where there's rotating or any type of moving part. That's considered as guard by location. And then, of course, you got the other type of guarding methods, what they call feeding and injection methods. This could be a good example. That would be a gravity-fed chute, maybe semi-automatic or maybe automatic feeding, and also injection equipment. Minimize the need for employees to be in the hazard area. And of course, the other thing, too, is what they call miscellaneous aids, such as an awareness barrier, something that says, hey, do not go beyond this point or do not put your fingers in this particular location. That's just one example that you may find there as well. Different types of machine guarding methods. Basically, guards are physical barriers that prevent access to a danger zone and basically are fixed, interlocked, adjustable, and also are self-adjusting. Safeguards must also meet the minimum. These are the bare minimum as far as OSHA is concerned, general requirements. They also must prevent contact. Safeguards must prevent hands, arms, or any other part of the worker's body from making contact with dangerous moving parts. That's contact prevention or preventing contact. And then, of course, you got the secure as the other safeguard. Workers should not be able to easily remove or tamper the safeguards because a safeguard that can be easily be made ineffective is basically no safeguard at all. Secure or fasten guards to equipment, and guards should be tamper-proof so they are not bypassed by employees. And, of course, protect from falling objects. The safeguard should ensure that basically no objects can fall into moving parts. And that's basically protecting from falling objects. Safeguards also must have, once again, continue on with the minimum general requirements. They must create no other type of new hazards. A safeguard defeats its own purpose if it does create a hazard of its own, such as maybe it creates a shear point, a jagged edge, or even an unfinished surface that can cause a laceration. The other thing, too, is create no interference. Any safeguard which impedes a worker from performing the job quickly and comfortably might soon be overridden or disregarded. Allow safe lubrication. If possible, one should be able to lubricate the machine without having to remove any type of safeguards. And once again, this is all done what? Through the design of the equipment from the manufacturer. A safety device may perform one of the several functions. Once again, it may stop the machine if a body part is placed in the danger zone. Restrict the body part from the danger area during operation. Require the operator to use both hands on machine controls. Another thing, too, is provide a barrier fitting the operating cycle of the machine to prevent entry of body part during hazardous part of cycle. Those are basically safety devices is what those are referred to as. Here's some examples right here. The very far left corner of your screen that you're looking at there is an example of what they call a two-button control. In other words, you have to have both your hands on the two levers in order for the machine to actually do its job. Here's another example of a guard. Once again, you say, well, Greg, the blade's exposed, but as you're pushing this wood through, this guard is actually designed to rest directly on top of the wood itself, and it does protect the top portion of the blade and keeps the operator from coming in contact. Here's another example of a guard. It actually may have some type of, let's say, an interlock switch built into it, for an example. This happens to be a robotic type of machine that you're going to find in some industries. But before you can go in there and do any type of work, it's actually affixed. The guard is to the outside of the gate area. In other words, when that gate opens, depends on how they've got it wired up, but basically as that gate opens, the machine shuts completely down. It's considered zero power going to that particular location. Here's another example right here of a belt that's actually been completely guarded. It could be a belt or it could be a chain that's been completely guarded fully around that particular location. Remember those, what they call nip points. And that's one to kind of look for there as well to prevent that from occurring. Engineering controls that basically eliminate the hazard at the source and basically do not rely upon behavior for their effectiveness, offer the best and the most reliable means of safeguarding. Therefore, engineering controls must be the employer's first choice for eliminating machine hazards. That comes back on the employer. Once again, coming up with equipment, designing it where what use engineering controls as a means of protecting of the workers. Here's the OSHA machine guarding audit checklist. This is one that is used here at Oklahoma State University. If you look at the checklist, it's fairly simply laid out. It's either a yes or a no, or maybe it's maybe non-applicable to that particular situation. But the very top up here, we need to know what the building and also the room number is. Need to know that location right there. Need to know who the supervisor is or the principal investigator is for that particular area. Need to know the date that the audit was actually performed, and what kind of equipment are we talking about. Once again, be as precise as you possibly can on the type of equipment, and most importantly is who's the person doing the audit. Make sure they print their name, but also make sure they sign their name right beside their name to make it what? Legible, so it's able to be read. And once again, we got A, B, C, D on this particular slide right here. If you'll take a look at those, it's very straightforward. General requirements for machine guarding, and basically these are some of the ones that we're going to be looking for there. And of course, you come down to B. Once again, guarding of mechanical hazards. And number C up there, or letter C, evaluation of non-mechanical hazards. And last but not least, which is very, very important, is the training aspect of it. If you have an employee who does not know how to operate that piece of equipment or that particular machinery, do not allow that employee to operate that machinery until they've been trained on the safeguards, how to operate that equipment in a safe manner before they're actually turned out to actually use the equipment by themselves. If you go into this next part up here, protective equipment. What kind of PPE do you need to wear? Once again, if PPE equipment or personal protective equipment is used, it actually may create a hazard by being caught in the machine. These are things to kind of go back and look at. A protective glove can actually be caught in between rotating parts. A face piece respirator can hinder the wearer's vision. You may not be able to see directly in front of you or even directly down below you if you happen to have a respirator on, particularly a face fitting respirator. Eye and face protection must be provided to employees when exposed to eye or even face hazards or from flying particulates. Okay, remember this: safety glasses, face shields. Face shields actually considered as a secondary means of eye protection. So if you wear safety glasses, wear a face shield in conjunction with that. There's nothing wrong with that. But make sure that you do have the appropriate type of eyewear for whatever the hazard or the machinery that you're working around at that given time. Let's go to the other part, personal protective equipment. Once again, we give you some examples. It depends on what exactly are you doing. And once again, remember this. The PPE or the personal protective equipment that you're using, is it going to create a larger hazard if they wear it, or maybe it may be something you need to go back and look at the machine that they're working on, and may have to go back and add additional safeguards. So do remember this, that your personal protective equipment is going to be one of your last means of protection as much as you possibly can. So once again, go back to your hierarchy of control. Can you eliminate it? Can you substitute it? Can you do administrative controls? And then once again, maybe it's something that you may actually have to put a person into personal protective equipment. So that should give you some ideas right there. Even the most elaborate safeguard systems cannot offer effective protection unless the worker knows how to use it and why. So when you do your training sessions on machine guarding, let the employees go out and physically look at the equipment, see how things operate on that equipment. That should all be in your training. How this machine comes on, how it goes off, what are the guards, where they're located, how do they function in with this particular piece of equipment. Specific and detailed training is therefore a crucial part of any effort to provide safeguards against machine hazards. It is critical that your employees are trained on the equipment before they're turned loose to actually go out and use that piece of equipment. Thorough operator training should involve instructions, hands-on training, a description, identification of the hazard associated with that particular machine. They've got to know the machine. How does it operate? What are the hazards? The safeguards themselves, how are they going to provide protection? And the hazards for which they are intended. So in other words, if you have protection, what exactly is that protection? What's its intended purpose is what we want to get that information to the employees. How and under what circumstances safeguards can be removed and by whom. In most cases, it's going to be repair and maintenance personnel only. So when can a safeguard actually be removed? Under what conditions? That's all in your written program or your standard operating procedures for working on that piece of equipment. What to do? Let your supervisor know if a safeguard is damaged, missing, or unable to actually provide adequate protection. You've got to let the supervisors know, the administrative management know, so they can actually take that piece of equipment, get it taken out of operation, and most importantly is get guards built, designed, whatever they have to do to bring that equipment back to 100% of a safe operating type of piece of equipment. So that's where your training comes into place there. The other thing too is if you get a chance, go into the e-tool that OSHA's come up with. It's at OSHA.gov. Go under SLTC, go into e-tools, go into machine guarding, and it has a lot of great information that you have access to. We did provide that in this particular presentation. So once again, take advantage of that. Just some takeaways. We've talked about the OSHA regulation deals with machine guarding. We'll also talk about different types of dangerous mechanical hazards, where they're going to occur at, different types of motions. Once again, is it going to twist? Is it going to turn? Is it going to reciprocate back and forth? Those are all different types of motions. Types of machine guarding. Is it, once again, is it going to be some type of adjustable guard? Is it going to be a fixed guard? Or maybe it's going to be some other type of a new type of device that they've come out with, actually protect the employee while they're using that particular machine. What are some safety devices? Once again, we talked about different ones that you may find out there. Maybe interlock switches, for an example. That may be a safety device. The other type of safety device that you may run across with machine guarding, you may actually have to use two hands. That'd be another good example of a safety device actually installed on that piece of equipment. Don't forget about your employees and make sure your employees are trained. They need to know what the equipment does. They need to know exactly how that particular equipment, its main function is. What are the safeguards built in that particular machine? They need to know what that information is. And most importantly is how to run the machine, how to operate it in a safe manner. That all comes back to employee training within the workplace. So let's go right on to the other part. Got just a few facts and questions here. So what is the point of operation? People always say, Greg, what's the point of operation? Where am I going to find that at? That is actually where the physical action takes place. It's what they call a point of operation. Okay. In other words, if you have a gear and you have a chain and the two come together in one fixed location, that's what they consider as the point of operation. Do your employees need to be trained? And the answer to that is most definitely 100%, they have got to know what that particular machine does, how the safeguards work on it. And I mentioned that earlier. And the other thing, too, is if there's any changes to that equipment from when the employee was first trained, make sure the employees know what the new updates may have been to that piece of equipment. Maybe something's been added on, or maybe something's changed as far as maybe the settings or something like that. Let the employees know. And most importantly is make sure that the training has been documented. If that training has not been documented, it never ever happened. So please make sure you provide documentation, have the employees sign it, and make sure you keep a record or a file on hand for the training records. Who do I contact if the machinery is missing a guard? Goes back to your supervisor. It goes back to whoever's in charge of your particular department. It may be the principal investigator. It may be the supervisor. Maybe the shop foreman. Just depends on where you're working at. But you've got to let that individual know the machinery, once again, has a defective part on it. The machine also needs to be done what with? It needs to be locked out. It needs to be tagged out until the repairs can be made. Can I remove a guard from the machinery? Okay, that's another question always comes up. Well, this guy right here kind of comes back to your lockout tagout. Remember this, you may have to physically remove a guard to do any type of maintenance on that piece of equipment. Depends on what the machine is, who designed it, how it was designed. But remember, make sure you thoroughly lock it out and tag it out before any guard has been removed off that particular machinery. And most of the time it's either going to be for preventive maintenance work, or it's going to be for some type of maybe R&R, replace, repair a part from whatever part may have broke on that particular machine. But once again, that would be the only exception of when the guard could be removed. Remember, your maintenance is very, very involved as far as machine guarding is concerned. So with that said, I do thank you all for allowing me to do the presentation today. On the last slide we have right here, just kind of an overview of what the Oklahoma State University Environmental Health and Safety Department does. We take care of everything from fire, laboratories, emergency preparedness, environmental compliance. We talk about lab safety. We take care of occupational safety, OC health, the materials management, the waste, hazardous waste the university produces. We also do the industrial hygiene, the chemical hygiene, and of course we also do safety training as well. All this information provided to the employees to have access to. So if you get a chance, you want additional information, if you're going to the ehs.okstate.edu website, when you bring up that website, you can go in there and just start searching under different areas as far as what the particular issue you have a question about. And if you don't know, just pick up the phone and give us a call at area code 405-744-7241. That goes directly to our main office. Or you can actually send us an email at ehs@okstate.edu. I do thank you all for allowing me to share this information with you. Hope everybody has a wonderful day. Thank you.